All right, so here's some practice problems. We have a man pulling an 8.5, I didn't put it in there initially, but it's 8.5 kilogram bicycle up a hill using 55 newtons. If the hill is at an angle of 25 degrees, what is the acceleration? So we have our initial force applied to the bike. How about let's find the force that gravity is resisting, right? Since even if we're pulling still up, gravity is still trying to push it down. We've got force of gravity pushing it down. So let's find that Fg is going to equal our mg sine of theta, and that is equal to 8.5 times 9.8 equals times, and we'll say 25 sine equals, that's equal to 35.2 newtons. So we're pulling up at 55, gravity's pulling it down at 35.2. Let's find our F net. Say our F net is equal to Fa minus Fg, since our positive direction is up the hill and our negative direction is down the hill. And let's set that equal to 55 minus 35.2. So we get that's equal to 19.8 newtons. F net. We want to know the acceleration of that. Well, if F equals m times a, we are just going to divide this by the mass. So our a is going to equal 19.8 over m. So our a is going to equal 2.33 meters per second squared. Hope you guys understand how I did that, right? F net equals ma, ma equals 19.8, a is equal to 19.8 over 8.5. So we get that answer. All right, next question. If the mu k is equal to 0.44, what is the acceleration of a 68 kilogram box sliding down a ramp at 49 degrees? Let's draw our picture. Say that's what our ramp looks like. 68 kilograms. This is an angle 49 degrees, and it's sliding down that way. So our force of gravity is pushing it down. Our kinetic friction is acting against it. That's really helping it. It's sticking it. The kinetic friction is sticking it to the ramp, right? Not letting it slide as fast. So let's look at this. Let's first find what the force of gravity on this object is. So we know that force of gravity is always equal to mg sine of theta whenever it's sliding down this ramp. So our force of gravity is going to equal 68 times 9.8 times sine of 49. 68 times 9.8 times 49 sine, enter. Oh, let me do that one more time, sorry. 68 times 9.8 equals times 49 sine, enter. Okay, good. 502.94 newtons, right. It's pulling it hard. Our Fk is equal to our mu k times the normal force. And we know that our normal force, I've said this a bunch of times now, our normal force, which is the force that this box makes with the ramp, right? The normal force is up, this force of kinetic friction, and the normal force, they're sort of working together to make it stick to the ramp like that. It's the normal force is pressing up on the box, and the friction is pressing down so that when it tries to slide, it can't slide as well. So our Fn is equal to mg cosine theta, since that's in this sort of up and down direction from the inclined plane, it's going to be cosine. So So our Fn is equal to mg cosine theta. So we'll say that Fn is equal to 68 times 9.8 equals times 49 cosine equals 437.2 newtons. So if we want to find our total friction force, it's equal to our mu k, which we already said is 0.44, times our normal force, which we just found right here, is 437.2. That's times 0.44. That means the force of the friction acting on that box is equal to 192.4 newtons. Okay, it's asking what is the acceleration. So we need to find our net force on this box. The net force is equal to, let's look at the direction this is. The Fk, it's opposing it, so that's negative, and our Fg is trying to bring it down, so that's positive. So we'll say that Fg minus Fk. So our F net is equal to 502.94 minus 192.4. 502.94 minus 192.4 equals 310.5 newtons. And like we did earlier in this one, since our F net is equal to ma, we're going to set our newtons equal to ma to get our acceleration. So 310.5 is equal to ma. If we divide this by the mass, we get our acceleration. So let's divide that by 68, and we get an acceleration of 4.57 meters per second squared. Very good. Now, last question. If the acceleration of a 68 kilogram box sliding down the ramp at 33 degrees is 2.4 meters per second, what is the mu k? All right. This is pretty much exactly like the ed puzzles we've been giving you, so let's draw this out and look and see what's going on. You won't have to even worry about this last part of the question. Let's focus on the first part first. Now, I know that's not 33 degrees, but let's just pretend. And this is going down at 2.4 meters per second squared. And we have our Fk, and we have our Fg going down as well. Okay, cool. And this is 68 kilograms, 68 kilos. All right. Something interesting and something nice that we can do is we can say this. And I'm going to write this out in long form so you guys can sort of see what's going on. Our Fk is equal to mu k times Fn, right? The normal force. This is a force, and any force is equal to mass times acceleration. So our mass times acceleration is equal to mu k, and if we write our normal force out, mass times gravity times cosine theta, we get mass times gravity times cosine theta. Now, let's go ahead and cancel out these masses since it's the same on both sides. We get an A is equal to mu k g cosine theta. Great, but we can't stop there. This is the acceleration because of the friction, but we need to also figure out the acceleration because of the force of gravity. Well, we know that Fg is equal to mg sine theta, and we know that any force is equal to mass times acceleration, g sine theta. So if we cancel these out, we get acceleration is equal to g sine theta. Now finally, if you want to get a net acceleration, you have to add these two together. And it's very simple to do that. We see that our gravity is pushing it in the positive direction, like we want it to go down the hill, and the acceleration in the negative direction is the force that we feel because of the friction. So what we'll actually write out is our acceleration is really equal to g sine of theta minus mu k g cosine of theta. And that'll give us our big acceleration right here. But we shouldn't stop there, right? We want to find what this mu k actually is. So let's actually plug in our numbers right here and let's see what we're dealing with. So 2.4 meters per second squared is equal to g sine of theta. So 9.8 times 33 sine is equal to 5.34 meters per second squared minus mu k. I'm going to write this after we find 9.8 times 33 cosine equals 8.21 mu k. All right. Very nice. So now let's subtract this over. So we get 2.4 minus 5.34 is equal to negative 8.21 times mu. Okay, I should have done that the opposite way. That's fine. I'm actually going to start on another sheet of paper. This has some writing on it, but just try and ignore it. Turn it like that. And I'm going to start again right here. So actually, forget that I wrote this right here. Let's erase that. And let's just write it again right here. And this time I'm going to move this over to that side. Just add it over, and then by doing that, I'm also going to subtract over the 2.4. So let's say 8.21 meters per second mu k is equal to 5.34 minus 2.4. And let's divide this 8.21 divided by 8.21. Our mu k is going to equal this quantity right there. So 5.34 minus 2.4 equals divided by 8.21. Our mu k is equal to 0.36. Now the second part of this question is asking us how long is the ramp if it takes the box 14 seconds to reach the bottom? How long is the ramp? Well, we can do one very simple, easy solution. We know the acceleration, 2.4. We know the time, 14. We want to find the distance. We use our shortcut formula. xf equals 1/2 at squared. I want you guys to just be so comfortable using this formula right here and just always think, should I use this? Always your first guess, and if you can't use it, that's fine, move on to another thing, but always check to see if you can use this first. So we're going to find that I'm going to go ahead and divide this 2.4 meters per second in half, and then we're going to say it's 1.2 times our time, which is 14 seconds, squared. 2 times 14 squared is equal to the total distance of 235.2 meters. That's that.